ในโอกาสต่อไปนะครับเราก็จะมีสปีกเกอร์พิเศษนะครับสปีกเกอร์พิเศษของเราในวันนี้เนี่ยมาจากประเทศอเมริกานะครับก็มาด้วยตัวเองไม่ได้นะครับก็ถึงจะอยากมาก็คงมาไม่ได้นะครับอาจารย์เปาโลนะครับบลิกสตีนเนาะก็ผมขออนุญาตแนะนำนะครับอาจารย์เปาโลนะครับก่อนเนาะอาจารย์เปาโลเนี่ยเป็น Associate Professor นะครับที่ Teachers College นะครับที่ Columbia University ในเมืองนิวยอร์กนะก็เรียกได้ว่าเป็นศูนย์กลางของสถานการณ์ปัจจุบันนี้นะครับโดยพื้นเพนะครับอาจารย์เนี่ยเป็นคนบราซิลนะครับเกิดที่เมืองเซาเปาโลนะครับในบราซิลจบการศึกษาทางด้านวิศวกรรมศาสตร์นะพื้นฐานเป็นวิศวะนะครับแต่ว่าได้มาต่อนะครับศึกษาต่อทางด้านยานวิทยานะครับการเรียนรู้ที่ใช้เทคโนโลยีเป็นเครื่องมือสำคัญกับอาจารย์ซีมัวร์แพปเพิร์ดนะครับซึ่งเป็นปรมาจารย์ทางด้านนี้ที่มหาวิทยาลัย MIT นะครับหลังจากที่จบปริญญาเอกนะคือท่านเรียนโทที่ MIT นะครับจบเอกที่ Northwestern University นะครับอาจารย์ก็ได้ไปทำวิจัยที่มหาวิทยาลัยสแตนฟอร์ดนะครับโดยตัวอย่างผลงานนะครับก็คือเรื่องของ Fab Learn นะครับซึ่งเป็นโครงการที่เอาแนวคิดเรื่องของการเอา Fabrication Lab นะก็คือเครื่องมือพวกเลเซอร์เครื่องตัดเลเซอร์เครื่องปริ้น3มิตินะครับมาใช้ในบริบทการเรียนรู้นะครับในโรงเรียนในมหาวิทยาลัยนะครับก็ Fab Learn Lab ก็กลายเป็นเหมือนเป็นแฟรนไชส์นะครับที่มีหลายที่ก็รับเอาไอเดียตรงนี้นะครับแล้วก็ไปตั้งนะครับขึ้นอย่างในประเทศไทยนะครับก็จะมี Fab Learn Lab นะครับอยู่ที่โรงเรียนดรุณศิกขาลัยนะครับโรงเรียนนวัตกรรมแห่งการเรียนรู้ในมจท.นะครับแล้วก็เครือข่ายของ Fab Learn Lab ก็มีอยู่ทั่วโลกนะครับมีคอนเฟอเรนซ์ใหญ่นะครับที่เขาจัดกันนะมีคอนเฟอเรนซ์ที่อเมริกาในยุโรปผมเองก็เพิ่งจัดของเอเชียนะครับกับไปในปีที่แล้วก็เป็นงานที่มี Impact สูงมากนะครับนอกจากนั้นนะครับเปาโลก็ได้ร่วมมือกับมูลนิธิศึกษาพัฒน์นะครับซึ่งนำโดยคุณพารณนะครับอิสระเสนานะครับทำวิจัยด้านการเรียนรู้ในประเทศไทยนะครับมากว่า 5 ปีแล้วนะครับดังนั้นก็รู้จักประเทศไทยเป็นอย่างดีนะฮะโดยปัจจุบันนะครับอาจารย์เปาโลก็มุ่งศึกษานะครับโอกาสด้านการเรียนรู้ที่มาพร้อมกับเทคโนโลยีใหม่ๆนะครับไม่ว่าจะเป็นเรื่องของ Data Mining นะครับเรื่องของ AI เรื่องของ Learning Analytics นะครับดังนั้นผมคิดว่าตอนนี้ก็เป็นโอกาสที่ดีมากนะครับที่เราจะได้ฟังนะครับอาจารย์เปาโลเนี่ยแบ่งปันประสบการณ์มุมมองเนาะเกี่ยวข้องกับอนาคตของการเรียนรู้ในวันนี้ So hello Paulo can you hear me
Yes
I was just introducing you telling the audience about how lovely our snack is outside and how you can't have any Anyways,
that's very nice of you.
Thank you for being with us today, and I think your topic is very interesting, so the stage is yours.
Thank you. Thank you very much. It's really... can you hear me well and see me well?
Yes.
Yes, okay. So it's really an honor for me to be here, like virtually in Thailand. It's a country I have visited many times for both work and pleasure, and there were years that I was in Thailand almost 3-4 times a year, working on projects, educational projects in Bangkok, in Chiang Mai, and with Arnhem. So it's a country that's very close to my heart, and I have dear friends and very interesting projects going on in Thailand. So always a pleasure to be here, and unfortunately I cannot be there in person, but hopefully next time. So I will talk today about this idea of automation and artificial intelligence and what they will do to education, or what they could do to education, and if it will kill education or save it. And so I'm going to share my screen now to just show my slides. If you don't mind. So can you see my slides?
Yes.
Yes. Okay. Great. So this is my topic today. And Wait, well, you can see the full screen of my, yeah?
Yes, we can see it.
Okay, you can see I just changed the slides.
Yes.
Okay, so this is what I will talk about today. Automation will kill education, but we can still save it. And I always start my talks talking about my wonderful team of former and current students, collaborators, postdocs. So you can see here a bunch of my current and former collaborators. Some of them are graduated this year. Actually, a few are going to Switzerland, to the EPFL and UTC. Bertrand is at Harvard as a professor. Marcelo is at Northwestern. And a bunch are on AI-related companies, like my colleague Nancy Otero is now a fellow at OpenAI up to last year. And so we have a really amazing team. Many of those people have actually been to Thailand in recent years. So a lot of the content of this talk comes from them. So I want to, always, I like to acknowledge those people. So let me start by saying that education is a business that has always a vision and an implementation. So the vision is not something that you can prove. It's not something that you can do an experiment to show that it's good or bad. It's your vision for the future of education, and that's really hard to quantify. It's a little bit like if you are, your vision for the future of a country. The future is not, you cannot prove it because it hasn't happened yet. So a lot of what we do in education should have those two components separate. So first we have to think about what vision we have for education. And Arnon was talking about his vision, as I could tell from the slides, of how CMU should do its education in the future. And then there is the implementation. But unfortunately, a lot of times we don't see the vision. We don't see what's behind the implementation. We just go implementing things and buying equipment, buying technology, doing all kinds of projects and all of that. And we forget that there should be a vision. Actually, you can see my mother watching the talk over there. Maybe she should turn off the camera. But so a vision and an implementation. Often when we don't see the vision, it's because you are inside someone else's vision. So that's a really important thing to keep in mind. When you're just implementing, just doing things, just buying technology, coding, implementing, you often are inside someone else's vision. So it's really important to keep your vision, to keep your designs for the future of your system as aspirational. So this is where you want your system to be. Of course, it will always be hard. It will always be something that looks impossible, but you should never give up on your vision. And the implementation is a different thing. That's like what engineers do. I'm an engineer by training. Engineers, often you have a vision of, I want to build a bridge of, the longest bridge ever built, and people will say it's impossible, it cannot be done. And then you go and hire engineers and, do the best possible work you can to make that vision happen. So the reason I'm saying this is that I think it's really important to keep this in mind. In education, if you look at the history of the last 2 centuries in education, there are 2 basic visions. One vision is student-centered, and the other vision is content-centered. So one vision is about what I want my student to know. Do I want my student to be happy, to be motivated, to be engaged in learning? Do I want my student to be studying things that he or she is interested in? Do I want my student to have voice in the learning process? Do I want my student to learn, 21st century skills like collaboration, like complex communication, like problem solving, all of that? Or you can do the content-centered vision, which is saying basically we have a curriculum we have to follow it. The curriculum is the law. I don't care if students like it, if they're interested in it, if they're motivated, whatever, I don't care. We need to follow the curriculum because the content, the curriculum, the law, that's what matters. And unfortunately, for the most part, the content-centered vision of education is what has prevailed over the last 100 years. And just very recently, we have started to think about this new vision of a student-centered educational system. And one of the pioneers of student-centered educational vision is Seymour Papert. And Seymour Papert, actually, one of his great inspirations was a project he did in Thailand in the 90s, more than 20 years ago, with Konparon and others in Thailand, a project that was called Lighthouse. And you should learn about this project because it's quite an incredible project. But so let's look a little bit at this content-centered vision and what's the promise and what's the problem with content-centered vision. This vision that the content is here, we have to follow it. I don't care if you like it. So this idea of technology enabling a content-centered vision is very old. This illustration is from 1899, more than 120 years ago, from a French illustrator imagining the School of the Future. And you can see the School of the Future has this machine to grind books, and then the content from the books goes directly to the heads of the students using this magical headphones. And this is sort of the template of the content-centered vision. You have content, you have to put it inside the heads of the students. Just show it in, just push it in, and then they get all this content, and you're done. You're happy. So this happened later with the TV. So TV was sort of the big technology in the 50s that would do this work of pushing the content inside the heads of the kids, right? And then after the TV, there were many other technological attempts. There was something called the teaching machine, which were this kind of primitive kind of electromechanical boxes that would basically ask kids questions and then tell the kids would answer the questions, and then the machine would tell if the question was right or wrong. So those are from the 50s, and you can see, the people starting to talk about, will robots teach your children? And this is from the 1950s. So this idea that we could realize this content-centered vision back in the 50s was already there. There was this whole idea of machine teachers in schools, and you can see, this even before computers were like personal computers were a reality. They already had this idea of putting computers in schools in this way, the computer as sort of this content delivery machine, right? And then, of course, there were many other attempts, many other machines, and I have a collection of pictures and magazine articles from the 1950s and 40s and 60s about all of those machines that people had to teach the content, right? And if you look at those magazines, they had a lot of, there's like a ton of material, and I find it very interesting because a lot of the promises of this content-centered vision in the 1950s and 60s, the promise is the same as we see today. It's like, we'll have a machine that will teach kids, and much better, much lower cost, much higher quality. It's going to be a miracle, and kids will learn much better and all of that. The problem is that all of those attempts to build machines that will teach kids in a better way, in a lower cost, higher quality, and all of that, so far, all of them fail. And, again, I have a huge collection of those kinds of things, but if you look at what happened, for example, with Amplify, which is a big company with more than $500 million in funding in the kind of early 2010s, they had this enormous infrastructure. They were promising that tablets would replace all the materials, the teachers, and teach in a much better way. There would be smart software that would guess what kids need to learn and serve them videos and questions and materials and everything. And basically what research has shown is that those kinds of things really don't work. So this idea of personalized learning, that you have a machine serving the materials with no humans kind of in the process, quantitative research has shown that doesn't quite work. That this idea of AI or smart software or smart machines or whatever it is, kind of replacing teachers, that doesn't work. And there's extensive studies about that. Even like a project by Facebook in the 2017, 2016 called the Summit Learning Platform, with again unlimited resources, unlimited funding, also started to be canceled in many districts because students were not happy, teachers were not happy with it, and all of that. So the problem with a lot of those solutions for the content-based vision of education, for this idea that you can design software or machines that will teach without humans and all of that. The problem with that is that if you look closely at what the technology really is, it goes a little bit like that. You show people some content, you give them tests. If they don't get the tests right, you show the content again, and you keep doing it until people get it right? So this is what I like to call the glorified rewind button, right? That the assumption of those systems is that people don't learn because they haven't heard it enough times. So if you just repeat enough times, they will eventually learn. But we know from learning research, from decades of research, that it's not that people don't learn because they haven't heard enough times the content. It's not about repetition. It's about rephrasing things in ways that are accessible to people. So it's not just about repeating the same things over and over. It's not a rewind button. It's about providing people rich experiences that will allow them to get in touch with the content in ways that speak to their ways of learning, to their interests, to their previous knowledge, and all of that. So there have been studies also showing that, and this is a study that with 230,000 students of online education, and those are not what Arnon was describing as sort of a model where you have a hybrid system with online and offline components and all. This is just like online courses, right? Without any kind of design or any care for, without teachers thinking about what they do, without TAs, without anything. So what happens in those courses is that the people who benefit the most of those courses that are 100% online and static, so they never change, they don't have people tracking the students and answering questions and helping them and all of that. The problem is that those things benefit most students who are in the top percentile, so students who know a lot already. But the students who are in the lowest percentiles, students who are struggling, they really need more help. They need more of the social interaction of the classroom. Or they need, just people helping them, even if it's online, they need people helping them more. So one of the results of this studies was that if you don't do good design for online learning, for those kinds of things, the people who benefit are already the good students, and the bad students are, each time more and more behind. And there have been other studies. One recently published about scaling up behavioral science interventions in online education, and basically, this is again a huge study with 250,000 students, and basically the idea here is that what they found was that there is no miracle for online learning. Like, if you do some kind of AI intervention that nudges people to plan their learning better, or nudges people to fulfill the deadlines. So all of this kind of chatbots or kind of interventions to make people finish their task on time, or to plan better their learning and all of that. They tested a bunch of those, and they realized that they don't work at scale. They might work in some experiences, but when you scale them up for hundreds of thousands of students, they don't work that well. And often they work like, it reduces their efficacy by an order of magnitude when you scale them up enormously. So, I mean, this is not to say that online learning or that all of those things, that those things don't work, but that those things work when they are very well designed, very well planned, when they have, people with good training in education, thinking about those things, designing those things and all of that. But what they do say is that there is no miracle of high quality education at no cost. There is no miracle of a chatbot or an AI thing that will miraculously save education for hundreds of thousands of students at the same quality and all of that. So that's something we have to immediately erase from our heads. There are economies of scale, but it's economies of scale that are not miraculous. Right? They're economies of scale that are based on good design, on careful design, and all of that. So, anyways, another important reason why those things don't work, and this is the mid part of my presentation, is what I would call the Soylent phenomenon, right? The Soylent phenomenon. So Soylent is a product in the United States. It's basically a drink that was invented in the Silicon Valley by a former programmer. And basically what Soylent is, the way they invented it, they said, Soylent is a drink that has 33%, each bottle has 33% of all nutrients you need in a day. So if you drink 3 bottles of Soylent a day, you're done with food. You don't have to cook, you don't have to waste time eating. And in the Silicon Valley where people work a lot, this was like, okay, we can save 1,000 hours a year for each person, if you just stop this nonsense of cooking and just drink Soylent three times a day. So each bottle, 33%, drink 3 bottles and you're done. So what happened to Soylent? Right? So in theory, if you look at the ingredients, it has exactly 33% of calories, fats, vitamins, everything, right? So what could go wrong? But a lot went wrong with Soylent. So they have to replace it because people were like vomiting Soylent. And then people started writing in the press that, well, Soylent isn't really healthy. It sounds like an interesting idea, but it's actually terrible for the human body, and people were having all kinds of stomach, intestinal problems and all of that. And then when they started looking at it, they realized 2 things. First is that, the food you eat, it's not just about the calories, the fats, the sugars. There's a lot of stuff in food that we don't know exactly what's in there, but the body needs. So you cannot just extract from the food a few nutrients and say, okay, I'll put this in a bottle and people don't need to eat anymore. There's a lot we don't know about how nutrition works. So when you took the nutrients out and just gave the nutrients to people, a lot of stuff was missing, and then people started to have terrible health problems. And second is that it's not just about the nutrients. Having a meal, stopping working, stopping your work, having a meal with your family, cooking, those things have other functions, right? So what I call the Soylent phenomenon is that a lot of times in education we say, what we care about education is the content. So I create a robot that can deliver the content and I'll be done. I'll deliver the content and education is done. So it's like the Soylent. We deliver the nutrients without all the other stuff that comes with food, that comes with eating, and we'll be done with nutrition. But actually in education, it's not just content. So when you go to a classroom, either online or offline, it's not just receiving knowledge. You are learning about socialization. You're learning about collaboration. You're learning about how to read social cues, how to interact in complex social environments. You're learning to read, right, which is also something very important in all of that. So I think that, this idea of the soil phenomenon is that it's not because education is a lot about content that the other parts are not there. And when you just take content out of education and deliver it through a machine, it doesn't work because all the other stuff is not there, just like in soil. So let me now switch in the last few minutes to a more optimistic note and talk to you about where I think the opportunity is actually with AI and technology in education. So I think it's not for the technologists for teaching, the content-centered vision, but it's the student-centered vision, and I'm glad that Roger was talking about that a lot today. So many countries like Canada or the United States, they have created new national standards in which building, creating things, learning to code, learning to engineer devices became mandatory, not for university, but for high school and middle school. So this is the Canada, they created a whole new discipline called Applied Design Skills and Technologies. In the US, now it's mandatory for all students to create prototypes, optimize solutions, solve problems. So this is part of the national curriculum of many, many countries. And so, what's the opportunity there? The opportunity is that now in many countries, and I hope Thailand does that, many countries have rewritten their national curriculum to fulfill the student-centered version of education. So to fulfill this idea that kids and students should be building things, they should be doing hands-on stuff, they should be doing experiments, they should be doing things that are interesting to them and not just like receiving content without understanding what that's for, why that's important, and all of that. So let me just show you a couple of examples of what my students have done using AI in this vision of a student-centered education. So one is something called BioLab, done by my student Engin Bombacher and myself. And the BioLab is a remote chemistry or biology lab that uses AI to operate a microscope bank that can serve experiments to kids. So here you can see a quick video of, is a remote microscope being accessed by a child remotely. So there's no one in the room. This is all done through the computer. So this is an experiment with microorganisms. And not only the child can see the experiment through the virtual microscope, the child can also model how those things work. So you see the blue ones, for example, are virtual organisms that the child created and created a model to explain how they work, and then they can see them side by side. And all of the system is kind of managed by AI and kind of cloud computing ideas that we call it cloud lab. Like if one computer breaks, they can go to another. If one microscope breaks, the system automatically switches to a different microscope, etc. So that's one idea applied to science. I want to talk about quickly one idea applied to engineering. So now we are applying the ideas of learning analytics to engineering. So how to understand what students do when they are building things and making things. How can we do design assessments? How can we understand what you're doing? So in this case, my student Richard Davis designed this assessment or the system where kids get to build a gearbox. And what he did was to use gesture sensors and AI to look at the gestures of how kids were building this device, so we can see what's happening there, that we can tell how they are moving, what they're doing. We can look at their facial expressions and all of that. And we're using this system in many experiments to understand how people build things and how people create things. And this is an experiment with 24 students that we did a while ago. So that's a second application of AI is to understand learning in complex environments. A third application is Unfold Studio. So this is a programming environment created by my student Chris Proctor that uses AI and sophisticated machine learning to understand, for example, debugging. So how do students debug? So he created a system that can understand that using this AI kinds of tools. Another example is the Gogo board that I developed with Arnon Sipitakia, which is a robotics board that has 3 processors and can do things that no other robotics board can do. So we are thinking that, how would the robotics board look like if the board can help kids learn how to use it, or if the board can do facial recognition, if the board can recognize if a song is playing and can follow things around an environment and all of that. And finally, this is another project that I designed with Google, IDEO, and also with Arnon. It's a project for teaching kids, very young kids, how to program with blocks. So again, here, you can see it's a very interesting reconfigurable system. But the idea here is, how would you think of those kinds of learning environments and learning objects and learning projects if you add AI to them? So how would a system like this, like Google Blocks, how could it be if it would have AI algorithms trying to teach kids how to program, or trying to teach kids what's missing in a given program, or trying to guess what kids need, what kind of block they need, what command they need, what they're trying to do, and all of that. So, if you look at all those projects, it's a very different way to think about how AI can impact education. I talked to you about the student-centered, the content-centered vision first, and I talked to you about how this idea of content is missing a lot of things, that education is not just about content. And if you put an AI software or agent or chatbot teaching the content, you're leaving behind a lot of what education is about, and you're fulfilling a vision based on content that's not the vision that most advanced countries are espousing today. So in the student-centered vision, I think there is enormous space for fantastic technology developments, fantastic invention, and it's the kind of advancement in education that will not just create a generation of people that know the same things as the previous generation. And it's also not a generation that will learn by pressing the rewind button 1,000,000 times, right? Which is what a lot of this kind of AI systems do. So it's not about pressing the rewind system and learning everything again, but it's about this kind of new types of Lego-like environments and blocks that will not just teach kids by letting them repeat the same thing over and over, but teaching them by letting them build, experiment, construct, program, and that, I believe, is the vision of education that Highland should embrace, because that is the vision of education that will guarantee that a country will not be a country of repetition, a country of doing the same things that everyone else is doing, but a country where kids from middle school, from elementary school, they go to school to build, to invent, to create, and try to imagine what a country would be if after 10 years of invention and creation and doing all these amazing inventions, those kids are out in the world trying to solve problems, trying to contribute to society and all of that. I think this vision of the Lego block kind of education is much more powerful to me than the rewind button vision. And so with that, I will end. Thank you very much, and look forward to your questions.
Okay, thank you, Paulo, for this inspirational talk. I think it's very important for us as a university to understand the different perspectives of how people learn. And I think this, consume versus construct perspective is a very important foundation that we should all think seriously about when we design a learning activity or environment. So we're a little bit behind schedule right now, so I will collect the questions that we have and maybe we'll discuss that with you offline. Anyways, thank you again, Paulo, for being with us today. I know it's pretty late there in New York, so we appreciate your time and hopefully we'll have a chance to invite you personally to Chiang Mai University. Thank you.
Thank you, definitely. Thank you and have a great day over there for all of you.
Okay, thanks, bye.